Hey parents, it's me, Mrs. Terrell. As you know, tomorrow is an asynchronous day. I have sent little packets home for them to do tomorrow, but I want to make sure that you are able to help them and support them with their learning as they go through this process. These are all things that we've already done in class. I want to make sure that you are equipped to help. All right, so the first thing that you're going to see is subtracting using a bridge map, seeing analogies. Now, I keep saying, and even someone else has said, math is not the same as it was when we were little. I know in the 80s, when I was in school, it didn't look anything like this, but we are trying to improve the rigor for our students, help them to understand the basics of math in order to transfer their learning to fifth grade. So with that, we are using thinking maps for math. It looks like, it just looks crazy. I know you're looking like, Mr. Ray, I don't know what you want me to do with that, but I'm going to show you, and I promise you it's not as difficult as you probably are thinking once you see this. Okay, so this is the page that they received today. You see all my manipulatives and stuff, so I don't want to mess this up, but well, I'm gonna put it on top because I know the next class coming in, I don't want to have to restage the area for them. But anyways, this is called a bridge map, and it's for seeing analogies. So this is to this as this is to this. You remember, you probably did some of these when you were in high school, more than likely, but just look at it. How are these two related? However, these two are related is the same way that we're gonna show the relationship here. Okay, so I forgot one thing. This is subtracting, ladies and gentlemen. Okay, so 7,432 minus 6,122 equals 1,310. So we have to find a subtraction sentence that equals 1,310. What I've taught them is to always start in the ones place. You know that, when you're adding or subtracting, you start in the ones place. But we have a lot of babies that just, for whatever reason, I don't know where they got it from, but they want to start here, and I just continue to move them right back to where they're supposed to be. But the problem is sometimes they still get it right even when they start from here, so they think I'm crazy because they keep getting it right. So just encourage them to make sure they're starting in the ones place. Okay, so in the ones place, the answer is 0. So I asked them, what minus what is 0? And it could be any number that they can think of that you subtract to get 0. So except for a 2-digit number, we've had that too, where they'll put 10 minus 10 in the ones place, and I have to say, like, 10 can't be in the ones place. It has to be a 1-digit number in the ones place. So we could say 9 minus 9 equals 0. Starting in the ones place, move to the tens place. What minus what equals 1? 9 minus 8 equals what? Well, there are several ways you can get 1. 3 minus 2, 7 minus 6. It doesn't matter as long as that equals to the 1 here. And then we have 3. What minus what equals 3? 6 minus 3 equals 3. Okay, it doesn't matter how you get that 3. 9 minus 6 is 3. Okay, so moving to the next, I always tell them to put their comma there because I know I'm moving to the thousands place now. All right, what minus what equals 1 again, and we could say 5 minus 4 equals 1. So I want them to recognize this as a whole number. Yes, we did it digit by digit, but this is a whole number. 5,699 minus 4,389 equals 1,310. What is the relating factor? The relating factor is, it is all subtracting or difference. And I try to use difference because I want them to get used to seeing the word difference, because it's so prevalent, and they see it and decide that they want to tell, how is this number different than this number? Oh, this number has a 1 and this one doesn't, and that's not what difference means. So I want them to start seeing that with subtraction. So I would prefer they use the word difference as the relating factor. Okay? All right, so that is the front page. Then there's the back page. All right, this is adding, you know what? I put a brace map on. Oh, that is the brace map. I was thinking bridge. Yes, okay. Adding using a brace map, whole part relationships. This is the same thing. Very easy. They just have to make sure that they're following through the process, okay? All right, so let's use a brace map. To answer this question. And yes, there are 3 lines here. This is your whole number. And what we're really doing is decomposing. That's a word I want you to use with them. Decompose so they can get used to the math terminology. How can we decompose this number? How can we decompose this number? Decompose means to break it apart into pieces. So what I do with them is I want them to be able to break that 4 into 3 pieces. What plus what is 4? Because this is the whole, this is the parts, okay? Whole parts relationship. So starting, same thing, starting with the ones place. What plus what is 4? They can be any combination. 1 plus 1 plus 2 is 4. 2 plus 2 plus 0 is 4, okay? Moving to the tens place. What plus what is 9? 4 plus 2 plus 3 is 9. Moving to the hundreds place. What plus what is 3? 1 plus 1 is 3. Whether you realize it or not, some of our babies are really struggling with this concept, okay? And then finally, in the thousands place, don't forget those commas. What plus what is 6? We could say 2 plus 3 plus 1 is 6. So 2,141 plus 3,121 plus 1,132 equals 6. So, well, equals 6,394. Okay, so this is how you do the brace map. Okay, all right, we got that. One more page. In out boxes. They're very easy, but some of them might be confused because what we did with using our input output boxes this week, we used with our patterns. And with patterns, you put in a number, so you create a pattern with 4 pieces, and then you add, according to the rule, 2 pieces, and it equals 6. So the next pattern has to start with 6. Same thing here, plus 2 is 8. The next pattern has to start with 8. This is not what this is. It's the same input output charts, but I want them to understand that every time they use an input output chart is not for patterns. There are several different reasons that they might be used, especially when we are engineering. If you're going into field engineering, these are some things that are used into science. These are boxes that are used, input output boxes for scientists and engineers, okay? So they have to know, just know, do what the rule says. It doesn't matter that the output doesn't become the input, just like with our patterns. Patterns is different. This is different, and I want them to understand that when they do this, you do the same thing. 8 plus 4 is what? 9 plus 4 is what? 10 plus 4 is what? 12 plus 4 is what? Just do what it asks you to do. Follow the rule. Then this rule, same thing. It's just they haven't done the ones that's across, but it's the same thing as the one that's up and down. Add 7. 0 plus 7 is 7. 1 plus 7 is 8. 9 plus 7 is 16. 15 plus 7 is 22. Just put their answer in the box, okay? At the ones at the bottom, they have to figure out the rule because some of the spaces are empty, but they have to find the relationship between these two to find the relationship here. I can see 2 plus 4 is 6, so the rule must be add 6. 4 plus 4 is 8. 12 plus 4 is 16. 14 plus 4 is 18, so the rule is add 4. Okay? Sometimes the rule is subtract. They have to know that. Sometimes the rule is subtract. This is 10 minus something. Same thing here. So it looks like subtract 4. 10 minus what is 6? 10 minus 4. there. 16 minus 4 is 12. 18 minus 4 is 14. 19 minus 4 is 15. Make sure they put the root there. Okay? All right, ladies and gentlemen. Gentlemen's. I hope that you were able to understand. But I hope you were able to understand what I was trying to give to you. If you need any help or support, just let me know. Bye, y'all. Have a good Friday.